As you can imagine, the skill of the models is or ensembles is going to depend on the models, model formulations, model configurations, data assimilation, initialization, and ensemble generation, and so on and so forth. Anyway, when you do multi-model ensembles, you hope that each one brings some flow-dependent characteristic that's going to add to the skill when they are combined. So these are the key characteristics of the 11 S2S monthly operational ensembles, again from just alphabetically listed Australia, China, and Russia, and so on, and I don't know, Europe. This is the Russian one. Italian, Japanese, Korean, and so on, US. Okay, and the various initial perturbation methods that we talked about: bread vectors, lagged averaged forecasting, ensemble Kalman filter, and so on and so forth, and model uncertainty, explicitly quantified or not, horizontal resolutions, and the dynamical ocean, that is whether it's coupled or if it's a uncoupled run. So there is some that are not coupled, for example, many here. So Japanese also doing that. So resolution can be, so here is a high resolution, let's say this is a high resolution model with 60 levels and 0.70 or 60 kilometer resolution, but it's not a coupled forecasting. And the forecast length is typically a month or two, as you can see here. Number of ensemble members, perturbed and unperturbed, also vary, and number of runs per week also varies. So even if you are doing monthly forecasts, they can be done again several times a week. So here twice per week on Thursday and Sunday. CMA is doing every day, once a week, twice per week, and daily, and so on and so forth. So that gives you, when you combine them to produce, let's say, once a week forecast, there will be ways to combine them to increase the number of multi-model ensemble members, for example. All of them also have a reforecast suite for S2S operational global and monthly ensembles. So again, same models here. Number of years used in reforecasts also vary. So 1981 to 2013, 94 to 2014, and so on. Members run each week for reforecasting, also different. So you can see this is only running one for 1981 to 2010. It's just to derive the model characteristics in the forecast mode, as we said before several times, to know the biases the model has in its forecasts, and validation, calibration of various things, and so on. So initial conditions for reforecasts, when you do this long integration in a hindcast mode, ECMW, so the initial conditions for atmosphere and land, where they come from. So you are doing it in the past. So this is where forecasts and hindcasts differ, because here initial conditions in the reforecast mode are coming from reanalysis, which are themselves blended observation model products. When you do forecast mode, you're just taking available observations, doing data assimilation, creating initial state for integration, whereas when you go back and do it, you're potentially, let's say, introducing some artificial skill. But in the hindcast, it's not so much the skill, it's the consistent record of hindcasts or reforecasts that you want to use for model statistics and error uncertainties, model uncertainties, sorry. Initial conditions for ocean and sea ice, again from various reanalysis products, and so on. So that's something important to remember. This is just to confirm that indeed the model skills depend on, of course, season, region, processes, and also model configurations. So here are different model configurations for different years, DJF 2016 and 2017, and different models. So you can see for the Northern Hemisphere extratropics, and for the tropics in general you can see that there is a skill difference. Also there is a faster drop off here for this winter average CRPSS score, okay, of the probabilistic prediction of the 850 hectopascal temperature over the northern hemisphere and the tropics of the 5 Tiggy ensembles. Okay, so skill dependence depends on the intrinsic predictability of the system as well. This is another way to look at it, looking at RMS errors as a ratio of standard deviation and RMS of the spread with respect to climate standard deviation. The good skills should fit on this line here. So this is again for the same. So the main point here is of course to say that skills do depend on model configurations, data assimilations, and so on. This is the same one for 2017. This is for winter 2017, 850 hectopascal temperatures, and this is ensemble standard deviation. Although this is the spread. Sorry, here is the. Anyway, you read it. Okay, let me read carefully. I don't know why I'm fumbling this one. Winter 2017 average scatter plot of RMS error of the ensemble mean and the ensemble standard deviation of the prediction of the 850 hectopascal temperature over the northern hemisphere of the 4 Tiggy ensembles. Okay, and this is winter 2017 average scatter plot of RMSE of the ensemble mean and the ensemble standard deviation of the prediction of the 850 hectopascal temperature over the tropics. Okay, so this is the northern hemisphere and this is the tropics, and there are systematically larger deviations that correspond to the larger or shorter lead times and faster error growth or model uncertainties in this case as the lead time increases. Okay, let me come back and do the last podcast separately in terms of what is the future of the ensembles. The book summarizes the main points, so we'll go through that, and it's already clear what we said, that there are ensembling methods, there are data assimilation of importance for this, and model configurations, and how we do multi-model ensembles in Tiggy still is dependent on model configurations that bring in various skills. The main point of ensembling is always to see if ensembling is improving skill and reliability, which we argued that it does. Okay, so then we extended it to the Tiggy, which is the grand global multi-model ensemble, which has lots, sometimes more than 600 ensemble members. So obviously a lot can be learned by having so many ensemble members. Remember, with each model we were trying to optimize the number of ensemble members, because the skill saturates, increases with respect to reference skill as you increase the number of members, but at some point it saturates, right?